Let me try to embed the chat into the stream. I just want to know how would it look. Nice. That's really cool. But I don't watch my stream. That's the problem, right? So it's only for you, for someone who is watching the stream. But cool feature nevertheless. So Day 15. Rambunctious recitation. You catch the airport shuttle and try to book a new flight to your vacation island. Due to the storm, all direct flights have been cancelled, but a route is available to get around the storm. You take it. While you wait for your flight, you decide to check in with elves back at the North Pole. They're playing a memory game and are ever so excited to explain the rules. In this game, the players take turns saying numbers. One sec, I just noticed Coderbyte link as sponsor. Oh, it's not free. Not for me. In this game, the players take turns saying numbers. They begin by taking turns reading from a list of starting numbers. Your puzzle input. Then each turn consists of considering the most recently spoken number. If that was the first time the number has been spoken, the current player says 0. Otherwise, the number had been spoken before. The current player announces how many turns apart the number is from when it was previously spoken. So after the starting numbers, each turn results in that player speaking aloud either 0 if the last number is new, or an H if the last number is a repeat. For example, suppose the starting numbers are 0, 3, 6. Turn 1. The first number spoken is starting number 0. Second number spoken is starting number 3. The third number spoken is starting number 6. Turn 4. Now consider the last number. Oh, wait, I see. Now consider the last number spoken, 6. Since that was the first time the number had been spoken, the fourth number spoken is 0. Next, again consider the last number spoken, 0. Since it had been spoken before, the next number to speak is the difference between the turn number when it was last spoken, the previous turn, 4, and the turn number of the time it was most recently spoken before then. Turn 1. Thus, the number spoken is 3. Turn 6. The last number spoken is 3, had also been spoken before. Most recently on turn 5 and 2. So the sixth number spoken is 3. Since 3 was just spoken twice in a row and the last two turns are 1 turn apart, is 1. Since 1 is new, the 8th number is 0. Wow. The game ends when the elves get sick of playing or diner is ready, whichever comes first. Their question for you is: what will be the 2020's number spoken? In the example above, the 2020 number spoken will be 436. Here are a few more examples. Given your starting numbers, what will be the 2020's number spoken? Your puzzle input is as follows. Cool. We don't have a separate file for input because input is actually small. So we are creating a new directory, copying the most useful strings. Oh, right. We still want to read from files, just to not copy the strings. Okay, so how we are supposed to do this? I think rules are pretty simple. So for each number we should remember when was two last times it was spoken. Otherwise the current line announces how many turns apart the number is from what it was previously. Yeah, so we need to remember just 2 times when it was spoken. That we will store it in the map only. Then we will compute the spoken number, update the map with the spoken number, and that's all. Super simple. So spoken numbers can be repeated, right? Yeah, so we probably want to have a list, I guess, just to simplify things. We can have a pair. Since we have constant number of elements, pair will be just fine, but lists sound better for me. Oh wait, what if the spoken number was only once? So after this, wait, so turn 5. Next, again, consider the last number spoken 0, since it had been spoken before. The next number to speak is the difference between the turn number when it was last spoken, the previous turn 4, and the turn number of the time it was most recently spoken before then. Hence we have okay, so if we just set the number, it will output 0. Okay. So we have only 2 states. We will never have state where the number is spoken only once. We actually can have such state. Wait, so let's forget about the problem and let's imagine the list of spoken numbers. We have n numbers, so in the list we can have either one of the number or 2 or more of them. Because if in the list there are no such numbers, it means it never been spoken, so it shouldn't be considered. So meaning that after starting numbers are spoken, spoken. We will have only each number spoken only once. Okay, I see. So we will have map of lists, and the initial map is from let's read now starting numbers, start nums, read file head args, lines, and map read. Yeah. It works.
I'm blinded by the street lights. It's like I'm hiding in plain sight. So distant on the outside. I'm a wanderer covered in disguise. I'm blinded by the street lights. It's like I'm hiding in plain sight. So distant on the outside. I'm a wanderer covered in disguise. I'm blinded. I'm blinded. I'm a wanderer covered in disguise.
Okay, from list, and our list is start nums. That's interesting. So and we also need how long before it was, and this should be a value. But also it will be a list, because we will consider all all previous because we will use all previous instances. And what's interesting is whether should we cut list to 2 elements each time. I believe we don't need to do that because yeah, who knows? Actually, who knows? Because later in program we might access it more than 2 elements. So probably cutting to the length of 2 will be useful. But here now, when we constructing initial, we just need to zip let's actually do list comprehension, and we have X and Y, and the X will be something from start numbers, XY, start numbers, zip with 0. Yeah, and yes, what we need to do here is just to make a list. Of course we can do this with second, but I want to do this with list comprehension right now. So encounters. So what we will need to do right now is to... Alright, we need to remember the last spoken number, which we can do here. Easy, super easy. It will be last starts none. But the game should need encounters, map into the positions, and yeah, let's create a few synonyms, which is number, and we will have position also int. Yes, encounters allow spoken number. Cool. Yes, so we don't need init game. Game encounters, and we will have last spoken is last start nums. That's it. What we'll need, speak. Game and to game. Speak, so game encounters and spoken. So we have 2 cases to consider. Case yeah, what we are doing is we cannot do operator because no, we can, because we for sure know that last spoken is in the map. So what we are doing here is encounters spoken, and we question this and say okay, case. So there are 2 cases here. One is just one element X, then we'll return. By the way, so for game we need to update, and the game will be updated here with encounter. Okay, so yeah, because it's really update game with some number will be game, and encounters would be update, right? There is a function update, I believe. Import qualified data map strict as m update. Yes. Update we also prepend x this update is gonna be on not X, we need position, right? We also need last spoken, but we also need position. Yeah, and initial position is a length of start nums. So here we will have update on the key position, no, on the key X, and with position as a value. We also can take 2 because we will not need other elements. And we are updating encounters. Cool. Last spoken will be that number, and position is just next position. Basically everything is updated, so we don't need game here. We just need game with a capital G. Position +1. Okay. Sounds about right. So in case we have only one number, update game with number 0. In case we have x and xx, we gave x and y. We update the game with x minus y, and in case we have something else completely, we say error. Unexpected that the number isn't in the game. Okay, speak, and we speak a lot of times. So we basically iterate speak. Yeah, so why we take 2? to allow compiler to understand that we will not be needing the values of the rest of the list. So I hope it will be garbage collected, but I'm not sure how memory works in Haskell. Speak init game. Oh, we actually can filter by position. We don't need to calculate 2020 minus the length of starts num, because we know that position is length starts num. So what we can do is to drop while. Drop while pause less than 2020 or 2020's number spoken. Yes, and then we take head, for sure we'll have something, and last spoken, and that's it. Let's try to compile. Right, here you should have errors. 35. Yes, because we need to have indentation. Parse error on comma here. Yes. Not in scope X. Num. Constructor what? Position. Position with int. It doesn't matter, right? It's type synonym, so I don't understand why it's matter. Pause is in accepted num. I see, because the list and actual type is. Yes, right. So what we actually saying here is that we want this to happen. Yes. There is no example. Let's give an example. Amazing background music, much appreciated. You're welcome. Cyberpunk is here. Wow, I responded 9 minutes later because I was too much in the flow of solving the problem. By the way, this music is from Twitch soundtrack, so it's not get copyrighted in Twitch, but it is getting copyrighted in YouTube. So YouTube will have ads on videos, but Twitch won't, I guess. Example 2 is 132. Example 3, example 3 is 213. Example 4 is 123. Example 5 is 231. Example 6 is 321. Okay. Oh, Nichaido is streaming. Okay, I just want to solve this problem and I will go to watch streams. Oh, or what can I do? I can watch the stream and solve the problems at the same time. Amazing. I will need my headphones to do these tricks, and I will output something into headphones, something into dynamics, so something will be heard on stream and something not. So let's first of all main with all examples to verify them. Haha, given k is not an element in the map. Well, I need to fix this. update happens on the elements that exist. So what we need to have is malter. So maybe default value is just position. So now with alter we will insert as well if there is no element. But something is not working. Actual type is int, maybe int. Alright. So we need to have just. Oh, let's do it like that. So just can be put here. So if we say just and this function. Actually, we can do $, because dollars are right associative, so it will first evaluate this function and then just this function. But we don't need just, we need just compose, so that's become trickier. So to do this we actually need we need to use parentheses nevertheless. Again it will fix indentation. It's working. Example in. Oh yes, that fits into what's supposed to be there. Let's try then. Oh, the Nichado finished streaming for some reason. So let's try other examples. One in. Wait, but I created it. No, didn't I? Example 1. Wait, example 2. So there is no example 1. That's strange. 1, 3, 2. Example 1 in 1. Yes. Example 2. 1. No, it's 10. Okay, so something wrong. Maybe I put example 1 into example 2. So I consider the first example as zeros example, which makes sense a bit, but yeah, I won't rename everything then. Let's say move example to example 0 in. Yes. Yes, and it will work because so when I say example 2, it's actually example 3. Wait, no. Example 1 now is 1 when it's supposed to be. No, that's really fine. So example 2 is 1. Example 3 is 10. Okay, makes sense. So now what we want to do is to example 1 to move example 0 to example 1, and that's all. That should work. So now we have example 1, cool. Example 2, cool. Example 3, cool. Example 4, cool. Example 5, cool. Example 6, nice. Example 7, yeah, so let's run on our actual task. So part 2 should be harder. Impress the else issue you a challenge. Determine the 3 millionth number spoken. For example, given the same starting number as above. Given your standard number, what will be... I don't see how... Oh, I see. So they wanted to trick, like if your solution was to just find the previous numbers, it won't work here. But because I am saving the last encounters in the map, it will work just fine. Just copy main to star HS, and we will have less than this number, and I'm not sure it's 3 million, so I just copy it. Yeah, let's give other. No, it's the same examples, right? It's the same 7 examples. Star main example 0, example 1 in. Wait. You want to say that my solution is not best as well? So 45, 53, it's 8 digits, meaning 7 zeros, meaning tens of millions. And it should work just as well, because tens millions, it's 8, 7 is 10 to the power of 7. It should work. Why it's taking too long? I don't understand. So the problem isn't with the algorithm. The problem probably is with lists. I actually don't understand what's the problem. Okay, let's for example say that we will have another speak function which won't do anything at all. Let's say it will just update the position. So game position equals position plus 1. Should be easy, super easy. That was too long. That's correct answer, but it's too long. So main example 1. Wait, it still calculates a lot of. Why so? Like iterating 10 of million should be just fine. Oh no, wait. No, that's true. That's correct. And you see, this one was much faster. No idea. So you say Haskell is inefficient, right? Let's just compare. So we have test go. For I equals 0, I less than 3, and how many millions? 7 add 0. you will have 17 and 24, and 25 minus 17 is 8, which is just exactly what we need. And we say position equals 0 and positions plus plus, and we will position. So, and we run this test and we see immediately, right? And here we have a lot of time. What's that about? So iterate is inefficient. Or is it because it's a struct? And when we create a new copy of the struct, we shouldn't, right? Because I change only position. Can we make this code efficient? What I guess we can do is not check for condition. We actually can say drop specific number of elements, and it would be 3 and this number minus length of start nums. Because if, for example, we have no start nums, we have one start num, we will need to drop we will start with position 1, let's say we want to find 10th element, and we have position 1, and we will have in the list 10 elements. So we will need to drop 9, 1, 2, 3 and 9, and 10th would be our. So yes, this formula should work. Let's example 1 in. Okay, so we can say that it's not the condition which is hard, it's iterate which is hard. So what can I do? What can I do here? Right? I can do fold L as well, but fold L requires you to have a constant amount of, or rather iterate through the list as well. Maybe if we use lazy map, it would be easier. I don't believe this.
your direction in the blizzard of your mind. Hold on to what you got, reach out for that line. We scale the horizon in search of a sign, but all we can see is infinite wide. The colors are fading.
Maybe if we use Foldel with strict evaluation it will be better. I don't know. Let's first just use Foldel. Yeah, Foldel, and we don't care about the right side. So we will have game something, or let's say conspeak. No, we care about accumulator, but we don't care about right side. To do this, we will need to say game something and speak game. We will have accumulator init game, and we will have just a random list with
Hold on to what you got, reach out for that line.
actually we will have replicate undefined and amount of times to replicate. So each element in the list will have one application. So to get 10th number we need 9 applications to the game if we are starting with one. So I believe this formula will still work. So now we don't need to have drop. Now we don't need to have. We just print last spoken. And prelude undefined. Okay, why? Why so? Right? Because we don't use elements of this list. Ah, no. Yeah. It's too long. You see, Go does it perfectly. Stack over. That's fine. That's why we have fold prime. Wait. Fold L. Wait. Because you probably need data list for this. Wait. Foldel shouldn't use stacks. Six. That's incorrect answer, but that's fine because that's probably an error here in formula, which can be or -1. So What? It doesn't matter what is. No, I don't understand. Alright. Because you need to recompile. No, even after recompilation it's still... I don't understand. So just to make sure. How is it 6 if we are increasing position? How is it 6? Ah, because we use last spoken, and what we want to have is position here. We don't actually care, but so we see the same here, same speed. Changing from iterate to hold L doesn't change anything. Step back. It will just bring Stack Overflow. So that's embarrassing, right? Yes, it is. So let's use bang patterns then to improve the speed. We are already using a streak map. Okay, so what is lazy here probably is last spoken. So let's first recall how to do eager relation in Haskell. Yeah, we have deepsec here. Deepsec, which is H. Wait, deepsec. We should have something. We should have something which is standard. not separate package. Bang pattern, yes, here. With a bang pattern GCC extension. Yeah, let's use extension. How to enable extension? Haskell extension. Language extension name bang patterns. Okay, so what we want to be banged here is number here. It works, superb. We are still not using. Okay, so let's say we are content with the speed of just processing one element, which is still time. Can I measure time here? Yes, so you can say plus time. Plus time. Okay, fair plus time. Option for set plus t. S plus S. $20 seconds for this. Let's measure time here. Less than 1 second. Really? Now let's try to use bang pattern. It won't be better, but it would be better than Go, or on the same level with Go. But at least maybe it will increase the time spent on evaluating structs. still running. Bank project. Do you want me to describe the project? If so, that's not a project but just solving Advent of code. And right now I was solving everything in Haskell because Advent of code is not a competitive programming, so it doesn't require you time limit. But now I stuck into the problem that Haskell is lazy evaluation, so iterating through the 10 million iterations will take 20 seconds, and iterating and changing the structs, which internally doesn't change the struct but does creates a new copy of the struct, will take 2.5 minutes and much more memory. Even for iterations, for simple iteration you don't need memory, but it spends megabytes, 9 gigabytes, kilobyte, megabyte, yes. How is this 61 gigabytes spent? Kilo, mega, giga. Thanks. So basically I solved the problem because I can wait for 3 minutes to get the result, but I want to learn how to write efficient Haskell as well. So it's the same task, so I will just run it on task input. So what I used a bank pattern here on number because I thought that the problem is that I'm using iterate, and I also tried it with Foltel, and iterate would create a list of structs, and what we want to do is just to have one struct, so we will have a constant amount of space, so we will not spend time on allocating a new space. So I remember that there is something called IORef, and it's actually mutable reference in the IO monad. So it's actually more in concurrent program IORef operations may appear out of order to another thread. Doesn't matter, I believe. So So, and what I want to do here is just instead of iterating and creating a list, just to modify the IO ref each time. Let's try this and we will see how it will go. So let's remove bang patterns to be sure that it's not bang, which improves our code. Let's instead, we will have pure function speak still. But what we'll do, here we have iterate, but not really iterate. We want the function to be applied specific number of times. How can we do this? That's easy. We just say map m. No, we can say replicate, right? It will create a list, but also we have map m. Or for E also we have. I forgot, we need to look at this Google. For E? No. So what we want to do is to have int, to have some monad, and then execute it n times. Yeah, I don't see in the prelude anything about this. Probably something in control monad. For? Oh, we have for m. And for m, probably that's what we want. Oh, it's iterating through the foldable. I don't want to iterate, I just want to maybe replicate m. Yes, that's exactly what we need. Replicate m, and results, we don't care about them. So what we'll have, our init game now will be not really pure, but new IORF. New IORF, which will return IORF, and IORF can be modified. Modify IORF. So what we do here is replicate m, underscore. How many times we need to do it? Number of times minus the length of starts nums. And we will use the function we need to do is speak. No, the function we need to do is modify IORef, and modifying IORef with function speak. And that's it. Yeah, that's it. The only thing we need now is we don't need drop while, we don't need head or anything. Here we need just yeah, we will need last spoken print. So what we'll need, we read IORef init game. So it's now game, not init game. Yes, speak also on game. We need to pass IORef here. Game, read IORef game, and we need to print last spoken of this IORef. Oh, new IORef, modify IORef, yeah. Import data IORef, new IORef, read IORef, write IORef, modify also. Modify IORef. Just a typo. Main example 1 in. So it's still slow. Stack Overflow, sure. We have results, so just let's check it. That's not the right answer. Yeah, because yes, this is the answer actually. Stack Overflow. So where we got Stack Overflow? Are you saying that replicate m creates a list and then using concat instead of executing all of them? Oh, actually we can look up the code. Google. Replicate m. Loops with count, and it applies wait function. Yeah, that makes sense. are you saying that is it at least Stack Overflow? Okay, that's the right answer, but the performance is terrible. I don't know. So it says Stack Overflow, which happened when we used Foldel. And I guess the reason behind this is that in the replicate M definition, we are not strictly evaluating F. So it will construct a list of, or rather, a stack of applications. So it will call function, it won't call first function, it will just construct like that. The result of the first function should be applied to the this operator to the rest of the list, so it won't use it. I see. There is strict version of data functor, which is nice, but what we also want to have is a strict version of monadic functions. Yeah, but we don't want to have fmap, we want to have something like and we have only strict map. That's really sad. What we can use is so to use strict they use here secu. Yeah, that's a base function. And what they say strictly evaluate that and then return that. So what we'll do here, fold L. Yeah, actually we can do fold L prime, which is already strict. But we'll need a list of, yeah, list is not great. Let's say we have replicate M. Basically, we will copy all the replicate M code. Not really all, but we will replicate copy something. And we will not specialize. Oh, we have specialized for I/O. Wow, that's interesting. So I guess in the I/O we will see another definition for replicate M. But doesn't matter for me. Replicate M, that's fine. Except here, we don't want to have this one. We want to have F, secu, and the result. What do you say about that? Possibly incorrect indentation. Here is fine, here is fine. Should be actually fine. 27 slide. Right. about now? Yeah, we don't know whether it's control or main. Of course it's main, because control monad replicate M is useless for our purposes. Example 1. Stack Overflow. Where in the code you see Stack Overflow? Okay, maybe we don't need to secure just F, right? We also want to secure all this expression. Actually, let's say, oh, deep secu, I see. Secu gives you only one sequence. Yeah, I don't know how to do this. Okay, I really need to read something to do it better. So, not now. Let's just submit the version of the code which is simple without IRF, but yeah. That's embarrassing for Haskell.